Okay, so today we are starting off a new chapter. We are classifying quadrilaterals. You're welcome. So what I want you to do is on the blank side, write quadrilaterals at the top. And these are four-sided polygons. So anything with four sides. Quadrilaterals. Okay, so there are three special kinds of quadrilaterals. There are parallelograms, there are trapezoids, and then the third kind is kites. So parallelograms have two sets of parallel sides. Trapezoids have one set of parallel sides. And then kites have two sets of adjacent equal sides. Okay, I can break up my parallelograms into two types. They are rhombus and rectangle. rhombuses have 4 equal sides. And rectangles have 4 right angles. Okay, and then there's one shape that's both a rhombus and a rectangle. Do you guys know what it is? Square. So squares they have 4 right angles and 4 equal sides. Okay, and then there is a special kind of trapezoid. It's called an isosceles trapezoid. So it's the same thing as trapezoids. It has one set of parallel sides, and then the non-parallel sides are the same length, and they cross at the same angles. Is anyone filling this side up, or can I move on to the back side? Okay, so now we're talking about specific properties of special quadrilaterals. So if it's a parallelogram, opposite sides are parallel. They're also congruent. Opposite angles are also congruent. So if it's across the parallelogram, they're the same size. Consecutive angles, so 2 in a row, are what? What's it called when they add up to 180? What? Supplementary. And diagonals, notice how these two, once they cross, they're the same length. Diagonals bisect each other, so it cuts each other in half. The diagonal is going from one end of the corner to another. One corner to another that it's not touching. So rectangles have 4 what kind of angles? It has all the properties of a parallelogram. And it has 2 diagonals, the things that cross from angle to angle but not touching angles. Okay. So if it's a rhombus, it has 4 congruent sides. It has all the properties of a parallelogram. It also has, oh no, this one's different. Notice how my diagonals are making a right angle? It has perpendicular diagonals. And then over here, on this one, the diagonals bisect opposite angles. Okay, so if a quadrilateral is a square, it has all the properties of a rectangle. And it also has all the properties of a rhombus. Okay, so I am going to go over number 7 and then some on the back. So first I want to plot my points. Okay, so what do I need to decide on this picture? The one I just grabbed. Oh, I didn't freeze it. Unfreeze it. Not bad. That one. So the first thing I want to check to see is if it's a parallelogram, so I need to check my slopes. Remember the slope formula? Let's take off this lid. Is m equals y2 minus y1 over x2 minus x1. Or I can use slope triangles. So if I want to find my slopes, first one I'm going to do is between A, B. So how many am I going up and over from A to B? And how many did I go over? 4. So my slope for AB is 1/4. So which one do I want to check to see if AB is parallel to? BC, CD, or DA? DC. So how many do I go up and over to DC? Okay, then I want to do the same thing with the other two sets of sides. So I know this is at least a trapezoid. I need to check to see if I have two sets of parallel lines. So I'm going to go from D to A. How many did I go up from D to A? 4. And how many did I go over? 1. Okay. Then I want to do the same thing for BC. So how many am I going up and over? Up. 4 and over 1. Okay, so what do these slopes tell me? So opposite slopes are the same. So they're parallel. So I know it's at least a parallelogram, but remember if I look back at my chart, was parallelogram the end of the chart? Is parallelogram at the very end? No. So I have things underneath. I need to go check to see if it is a rhombus and a rectangle. So the first thing, since my slopes are opposite reciprocals, it means they're perpendicular. Let's take away this thing. Wait. No, they're just opposites. Reciprocals. So they're not perpendicular? So it's not a rectangle. And then notice when I did my slope triangles up here, all of them have 4s and 1s. So if I use the Pythagorean theorem on one of those, all of them would have the same C value for the blue line. So the sides are the same length. What kind of parallelogram does this make this? A rhombus. It did not leave me any room to write the word. Some of them will be easier, though. It's just because this one turned out to be a rhombus. Okay. Can I go to the back? Okay, I wanted to go over... Pick a shape. Kite. Okay. So remember, I told you kites. These two are the same length, so what I want to do is I want to set those two equal to each other. So I'm going to have 13 equals x plus 2, and I want to solve for x. So how do I solve for x? So I subtract 2 on both sides. I get 11 equals x. And then this picture also has a y value. So these two are also the same length. So I'm going to have y minus 6 equals, and then instead of x plus 12, because I know x is 11, I'm going to plug in the 11 from my answer above. Then what do you want me to do? How should I solve this equation? I probably want to combine like terms over here first. So 11 plus 12 is 23, and then I can add my 6 to both sides. Y equals 29.